endoplasmic cell membranes? Would they fit here or here? They all said they are bacteria, exactly. Eukaryotes are bacteria. That's where would they fit. With the cell wall, same thing. Start with bacteria, let's say, although it's going to be a much bigger topic, so we'll have to move our K all the way. Let's say over here. But with bacteria, let's talk about the general structure of the cell wall. Right? First of all, you have to remember it is NAG-NAM that are connected with beta-1,4 bonds. So NAG-NAM, this is the beta-1,4 bonds. What you probably can do is, and remember there's a tetrapeptide attached to it. So you do have to know the structure of that tetrapeptide. Let's see, L-ala, D-glutamic acid, and let's call it R3, T-alanine. And so this R3 is what differs between gram-negative and gram-positive. You do have to remember that. I'm not going to go through all the details here. But this is the general structure of the peptidoglycan. Now this 3 is linked to what in the next chain? To the R4. So you have to remember that the cross-linkage is typically R3 to R4. So we're running out of space here, but let's say you have one going in reverse direction. So let's say you have let's draw it here. You have NAG, NAM, another one. You would have the 4 amino acids coming out of it this way. So L-ala, D-glutamic acid, R3, whatever R3 is, residue 3 that is, and finally D-alanine. The cross-link is between this R3 to this 4. Now this is where they can differ in gram-negatives and gram-positive. In gram-negatives it is direct, in gram-positives it is what? An amino acid chain. That's the big thing about the cell wall in general. But you have to be also, I guess we can branch it out this way, and that way. Yeah. It can be gram-negative, it can be gram-positive, right? What's the difference other than the cross-linkage? In gram-positive bacteria, it is a thick peptidoglycan, so thick PG, but less complex. Here, gram-negative, it is thin PG, but it is more complex. Is there something that's here that's not there? Can anyone remember? Does anyone remember? Something that is in gram-positives but not in gram-negatives. Excuse me. Teichoic acids, exactly. So it will be another term. I'm not going to ask you what is the composition of teichoic acid, and so far it doesn't make sense what we're saying, that the gram-positive is thick but less complex, and we're adding teichoic acid which is not there. So how can this be more complex than this? What does the gram-negative have that this one doesn't? Well, before the LPS, it's actually the outer membrane, right? It has a big outer membrane that the gram-positive doesn't. And then you can break it down into its 3 components: lipopolysaccharide, core polysaccharide, and the O antigen. Actually, never mind, my bad. The outer membrane has the LPS and 3 other things that we talked about. They have the porins, right? They have bronze lipoprotein. You can review them, but just and Bayer's junctions. Bayer's junctions. Now the LPS is the one that can be divided into the 3 parts. You have the lipid A, the core, and the O antigen. So I'm spending more time on the cell wall just because it's it deserves it, and then you're going to get a lot of questions from the cell wall. But any questions about any of the material? Now, with archaea, then what you could do is, first of all, actually, there are some exceptions to the cell wall that you'd have to know. Right? And we talked about only three big ones, right? Mycoplasma. What's unusual about mycoplasma? It lacks a cell wall. So how does it compensate? It has extra sterols. Thermoplasma is a what? Thermoplasma is an archaean that lacks a cell wall. How does it compensate? It has the tetraether, one layer, right? And finally, Mycobacterium possesses a cell wall, but it's unusual. Why? It has modified peptidoglycan, lipoarabinomannan. So these are other terms that you have to remember. Mycobacterium, it has mycolic acid, it has lipoarabinomannan, it has arabinogalactan. They are in the notes, so but I'm just, and please remember, this is not an exhaustive list. So if I don't write it on the blackboard, it doesn't mean that it's not going to be on the final. But I'm just giving you really the ones that come to mind. Archaea, right? So then we can talk about archaeal cell walls. First of all, do they have peptidoglycans? One remember. They don't have peptidoglycan. They have pseudo peptidoglycan, and you have to be able to differentiate it from regular peptidoglycan. So this is called pseudo PG. How does it differ? First of all, there is NAG still, but now NAT, N-acetyl telosominuronic acid. We'll save 2 seconds and not write it. They have NAT, they have beta what? Beta 1, 3, and they have no D amino acids. Whereas this one, where is it? This one has D amino acids, which are unusual. This one doesn't. So they're all L amino acids. These, if they do have pseudopeptidoglycan, it will stay in gram positive. If they have the S layer, it will stay in gram negative. It's in the notes. Any questions about, excuse me, cell wall? So any questions about the cell wall? Oh, there's one more thing. What entity breaks the beta 1,4 down? Without lysozyme, exactly. What we have talked about that blocks this crosslink from forming. These are some of the things that I was telling you about. You'd have to relate between two chapters. We talked about which antibiotic blocks this formation. The beta-lactams, exactly. All the beta-lactams, including penicillin, would block this one from happening. Right? So please remember that as well.